Welcome to a short video introduction to ICU Workbench, recognized as the leading software solution available to assist investigations and missions that utilize various forms of location-based surveillance. Capturing location data from surveillance missions is commonplace. The challenge is finding the true intelligence hidden within the data collected. The ICU Workbench software solution is the leading solution available for finding the intelligence hidden within the millions of GPS data points. What ICU allows you to do is move beyond the traditional view of dots on a map capability that accompanies most GPS tracking devices or similar location-based monitoring technologies. ICU rapidly provides patterns of movement over any period of time for an individual or group of individuals and answers the very difficult question of who meets who, when they meet, where they meet, and how often. ICU will also answer the equally challenging question of tell me with a 90% confidence level where my target or targets are going to be next Friday. This intelligence can be instantly available when ICU is presented with hundreds of thousands of GPS data points. We have gathered a few quotes from some of our users. I will let you read through these. As you can see from the illustration, there are multiple ways to get your GPS track files into ICU. You can import directly from CSV files that would contain an extract from any commonly used surveillance device. You can also use a data repository, which can be comprised of a series of CSV files or a data structure that is specifically designed to store the data coming in from your surveillance devices. The input into ICU from a data repository is a fully automated function. Your user community can be comprised of a series of users accessing the fully analyzed data via a standard web browser in a web implementation, either hosted internally or externally. You can also opt to have a group of standalone or super users work with the desktop versions of ICU and the advanced features this deployment provides. Both user groups can access the same database of information. We will now move to a short video demonstration. For the first portion of this presentation, we'll be looking at a track file from a GPS tracker placed on Tom's vehicle over 51 days. It's comprised of 62,000 data points with 5-second interval GPS fixes. What we're looking at now is the itinerary grid. The itinerary is a color-coded grid representing the target's pattern of life. Below is the legend, and we can see that light blue represents home, a darker shade of blue represents work, purple indicates time spent at destinations other than home and work, and green indicates some travel or more travel, depending on if it's a flag in the corner or a solid green cell. You can see along the top, every day is represented by its own column, and every hour of each day is broken down along the left-hand side. You can easily scroll through one day at a time or 2-week periods at a time to find the appropriate time frame in the track file that you wish to investigate. The cell is interactive, so if you hover over a cell, you'll be able to see what was going on during that hour. And within each cell, you can zoom to a location, see the target location's profile, and edit the location. We'll start by zooming to this destination, and I can see that this is a grocery store. If I go back into that destination and edit, I can assign it a more finite address because I'm familiar with this area. I know it's 616 Main Street. We can assign it an icon on the map, and we know it's a grocery store. And we can assign it a level of interest. When assigning a level of interest, it's 1 through 5, 5 being the most interesting location, and 1 being the least interesting location. we will assign a level 4 level of interest to the grocery store. If we had surveillance notes or other notes we may want to add in, we're able to do so on this panel. We can save the grocery store information, and it will do a couple of things. One, it changes the cell from purple to blue, so we've identified this destination. It also changes the icon that shows up on the map is now identified as a grocery store. Icons that appear on the map are interactive. So if I select the grocery store, I can see what address has been assigned to that location, how many times the target has been there, between what date range, and how long they'd spent there, aggregate of all their visits. We're also able to plot travel to and from destinations. I can select one or multiple cells around the grocery store and update the map, and it will show the travel from home to the grocery store and time returning home after. You're able to select what appears on the map. Currently I have fix pins turned on, and now every fix that shows up on the map is interactive. If I were to turn off fix pins, we get a more well-defined travel line. If I want to distribute this map as a report, I can select the map icon, and it will take a quick screenshot of what appears on the map for easy distribution. Some other reports we're able to generate from the itinerary panel is the itinerary report, which provides a chronological overview of the target's activity for every day for the entire track file. We can see on Friday, March 26th, Tom arrived at home at 9:34 in the evening. He left for work at 8 a.m. He went somewhere during the lunch hour period, and then back to work, and then at the end of the day returned home at 5:21. You can easily scroll through for any day of the entire track file. Another report we can generate from here is the Daily Highlights report. The Daily Highlights report provides the user with a high-level overview of what the target was doing that day. First, we see a pie chart that shows what the target was doing. He spent most of his day at home and a little bit of time at other locations and traveling between destinations. Also on this panel, we're provided with a list of new destinations where the target has visited that he has not visited before. We can see that destination 16 on Eisner Boulevard in Dartmouth, the target went there for 10 minutes and 20 seconds, and up until this day, he had not been there previously. We've also notated that the grocery store is a high-interest destination. So now every time the target visits the grocery store, because we've assigned it a level 4 level of interest, we'll be notified on the Daily Highlights report. Also, a list of other brief stops Tom made during the day is listed. All reports within ICU Workbench can be saved in a number of different file formats, including PDF and CSV, for easy distribution. When looking at the pattern of life grid, you can apply a number of filters to change what is displayed. If I turn the filter on and select Monday, the pattern of life grid shows now every Monday during Tom's 51-day track file. This is helpful in finding repeat patterns, focusing on a particular day or time or location that might be of interest to you. The second tab we'll take a look at is Destinations, where the itinerary panel is what a target is doing during a particular time window. Destinations provides a complete list of all the destinations a target visits. We provide a unique ID for every destination. We list the frequency of visits. We can assign it as a hub. We're able to group destinations. If Tom was a drug dealer and he went to 3 drug stash houses, we may want to generate some reports where all of those destinations are listed at once. We're able to assign an icon. We can see that the grocery store icon we previously assigned carries forward. We also assign a destination name, which is the address provided via a reverse geocode. We also list the target's minimum and maximum stays at every destination, as well as his average stay. Lastly, we can assign a level of interest to every destination based on how important it is to the investigation. On the right-hand side of the map is a representation of all the locations Tom visits, shown with either a red push pin or an icon that we've assigned onto the map. If we go back into the grocery store and zoom to that destination, we can generate a destination profile. The destination profile is a graphical representation of all the time Tom spends at the grocery store. We can condense it down to only show days when Tom visits the grocery store, or expand it to show the entire track file. We can also go in and overlay additional locations that we want to show on this report. We're also able to apply filters, much like with the pattern of life grid, if we wanted to only show Saturdays and Sundays, or any other day combination, or alternating days. We're also able to select varying date ranges, or also show varying levels of interest for locations. Next, we're able to take a look at the destination details, or the visits list, where we're provided with a list of every visit Tom made to the grocery store. We are provided with a date, the day of the week, his exact arrival and departure time, the duration of the visit. A particular interest here is the coming from and going to locations, where Tom went immediately before and immediately after. If Tom was in fact a drug dealer and he sold drugs in this parking lot, perhaps Destination 6, or the Highway 7 location in Westfall, may be where he's picking up his drugs before he goes and sells them. We're also able to assign a level of interest for every visit. So if Tom was actually surveilled selling drugs on this particular visit, we want to label this as most interesting, and maybe add some notes that he was drug dealing. On the map, every visit is interactive and represented by an orange pin. If we click on one pin, we're provided with the details of that visit that corresponds with one from the visit list. On the destination panel, we're able to select locations as hub locations. Currently, home and work are selected as hubs, and we can now generate route reporting to and from those destinations. Looking at Tom's work commute, we can see he went from home to work 39 times. When Tom makes that standard commute, all of his travel falls within this polygon. Sometimes he does make stops along the way to these destinations, which also fall within that polygon. Tom also makes 6 transits that are considered a variation of his standard travel. If we update the map to show those, we can see the polygon grows considerably, and we're presented with a list of a number of destinations Tom deviates to. This map is interactive, so if we were to select one location, we can see when he visited and deviated on his standard work commute. We could also list partial transits where Tom does not quite make the full trip between home and work. With high-quality GPS tracking data, you're able to understand driving events for a target, such as speeding, hard braking, or lurking around a certain area. Maneuvers such as speeding or hard braking may indicate counter-surveillance maneuvers. Each of these driving events is able to be clicked on and interacted with on the map. Circling back to the itinerary panel, we can show some of the advanced features only available on the desktop version of the software. The predictions module generates a recurring cycle for the track file. Tom is an office worker Monday to Friday during normal business hours and spends most of his time at home on weekends. So his recurring cycle would be 7 days. Much like the pattern of life grid, this recurring cycle is interactive, so if we were to hover over a cell, we'd be provided with the details of that hour. So Tuesday at 2 a.m., Tom spends his time 7 out of 7 days at home, a 100% prediction. Anything in white signifies a prediction which does not meet the prediction threshold, in this case, 70% accuracy. Hovering over Wednesday at noon, we see 3 out of 7 days he's at destination 10, and several other destination activities during that hour which do not meet that prediction threshold. We can adjust the prediction threshold to see only locations with a high prediction threshold or low, and adjust to show the whole duration or partial duration of the hour. Now we are looking at all the times Tom is predicted to be at a location with a 99% or higher prediction. The grocery store on Saturday at 11 a.m., Tom spends at least a portion of his hour at that location. Friday nights are the only night during the week where Tom does not spend his night every night there at home, 7 out of 8 times. We can adjust when the cycle starts and ends. For example, if Tom was to change his home address halfway through the investigation, we might want to adjust to accommodate that. Or perhaps we only want to look at the most recent data, perhaps the last 4 weeks of data, to find a prediction. We can also change the duration of each cell. We could break it down to be as little as a 15-minute window or as high as a 12 or 24-hour window to find a prediction that he visits a location on a particular day. The next tab we'll take a look at is the Compare tab. Compare allows you to overlay multiple track files from one or multiple individuals on one map at one time. Today we'll be taking a look at Tom, and specifically Tom's GPS data, his phone records, and his Twitter and Visa activity. So if we scroll over here to March 27th, we've already looked at Tom's GPS activity, and we can see for a 3-hour time window where Tom went. Can then overlay his call records on the map at the same time. Shown in blue, we can see where and when Tom is making and receiving phone calls. For each call, we can import a descriptive column, including who's calling who, how long the call lasted, and what tower the call was made on. If Tom's phone calls were not along towers along his travel route, perhaps if he was making and receiving phone calls in Burnside during the same time his vehicle was driving over here, that may indicate that Tom was not in the vehicle as it was driving around. Perhaps he lent it to his girlfriend or wife for the day. Then we can go in and select his Twitter and Visa transactions. And we're then presented with 4 different track lines that are all flowing in the same direction at the same time. So we may want to go ahead and fuse these disparate data sources together into one track file. Now I've already gone ahead and done that. And if we take a look at the Tom fused track and plot it out on the map, we can see now in dark red his travel line, phone calls he was making, tweets and purchases he was making along the way. Going back into Tom's GPS itinerary report, you may recall we had a report with about 15 or 20 lines of data showing his movements. By taking those disparate data sources and fusing it together into a single track file, we're now presented with a report that's much more comprehensive, 3 pages, showing where he goes, what he's doing, including his purchases, his tweets, and his phone calls. For data sources like Twitter that are only providing location information 6 or 7% of the time, you're able to provide additional context to those tweets. The next panel we'll take a look at is the multi-target analysis. There's 2 versions of multi-target available within the ICU Workbench. On the web or enterprise-based version is a one-to-many comparison where you can select one vehicle and compare that one vehicle to all the other vehicles in the same folder. Or, in the example we'll show today, the many-to-many comparison found in our desktop version that allows you to compare all the vehicles in the folder to all the other vehicles in the folder. We're going to take a look at the Law Enforcement NCIS folder, which contains 6 vehicles, and we're going to be looking for meetings. So very quickly, we can select the folder we want to analyze. We can select the geographic proximity that 2 vehicles will need to be in range of for it to be considered a potential meeting. And since we're looking for meetings, we're not going to have any drop-off allowance. We want to see time overlap. So in a matter of seconds, we'll run the analysis, and we'll be presented with the results. 2 things will stand out here. We have a number and a color for each cell. Looking at the black Titan and the Audi, they have 30 locations in common. And when we interact with the grid of those 30 locations, we can see that there are no potential meetings between them, or as per the legend below, no meetings. Now red would indicate most interesting. So for the copper Titan and the white van, we have 27 locations in common. And of those 27 locations, 6 are shared locations that could involve potential interactions. If we go and examine the interactions for these 2 tracks, we'll be presented with a list of all the locations where potential meetings took place. From the list of meetings, we can select one meeting and examine the potential interactions at that location. This particular meeting, there was one potential meeting between these 2 vehicles. For some of the other locations, we're shown a list of how many times the vehicles went there, as well as how many potential meetings took place. Looking at the meeting at 1104 Carver Avenue, we're able to see when each vehicle arrived, when they departed, how long they were there, and what the overlap time was. This particular meeting appears to have taken place just outside of a trailer park. We're able to plot their travel on the map and show that there is a connection, as well as represent where each vehicle came from and went to afterwards. We can see that the green travel line, the vehicle came from just to the north, while the white van came from a considerably further away distance to attend that meeting. In the case where multiple vehicles may be meeting at one location at the same time or different times, we're able to kind of create a shared location profile, which will generate a calendar view of all the time all the vehicles within that folder visit a particular destination. We can scroll through the calendar to see when vehicles are there, how long they're there, and with what level of interest the potential meetings are. The legend here shows that anything in red is considered a most interesting meeting, meaning that they're closest together. The less interesting it becomes, the further it slides down the scale, all the way to gray, when no meetings are taking place, but at least one vehicle is present at that location. Instead of looking for meetings between this set of 6 vehicles, we might be interested in locations that they have in common. So we'll select the same data set, and instead of using a geographic proximity of 100 meters, we'll shrink it down to 30 and run the same analysis. Instead of selecting a cell to see how 2 vehicles are connected, we can take a look at all shared locations, and we'll be presented with a list of all the locations where 2 or more vehicles potentially met. We can uncheck this box here to show that time is not important, so we're only looking for locations that are in common. We're now presented with a long list of all the locations where 2 or more vehicles have been at any point. For this particular location on Cypress Avenue, this may be of interest because 5 out of the 6 vehicles in this investigation visited that location. If I zoom to that location, I can see that this is a residential address where these vehicles have frequented. I'd like to thank you for taking some time to explore the ICU Workbench and how our military-grade solutions automatically and rapidly answers more than 40 of the most commonly asked questions from analysts related to tracking of an individual. Track Group Solutions, built by agency analysts for agency analysts.